Hey, once again, everyone, welcome to the Programming Languages panel. This is really exciting to have a lot of folks here that can contribute to the discussion. And but myself, I'm a long-time Scala big data developer. I've also been getting into Rust lately and have to do Python for data science. And once upon a time, I remember when I worked for VMware for many years, I got into Python and said, hey, this is it. This is all I ever want to do, and obviously, there's been a lot of evolution. I've learned Ruby. So, I mean, I think this is always, the programming language is always like religion, like everyone is always debating about them and everyone is really passionate. So we're looking forward to a good, passionate discussion here. And I think my main thing for everyone else is really around to start off with, where do the rest of you see in terms of the programming language landscape and how it is serving the needs of the cloud today with so much distribution, concurrency, and with developers getting involved in operations and where do you see the current landscape and how it contributes to it? So Wiem, you want to introduce yourself?
Yeah, hello everyone. I'm Wiem, Zine Elabidine, and I am working as a software engineer at Moya. Moya is a company based in Hamburg, Germany, for ride sharing, and it is based we are relying on the a lot of information about where the vehicle is and having a lot of components and services that are interacting with each others. So we are working a lot with distributed systems. And I'm excited to hear from all of you about this topic. Welcome everyone, and you can introduce yourself. Maybe we can start with Jon Pretty.
Okay, hi everyone. I'm Jon. I'm often known online as Propensive. I'm a long-term Scala developer. I've been using it since 2004, and not entirely sure why Alexy's invited me onto a panel about the cloud, but I do use Google Cloud Platform. I suppose my interest in would be in relating Scala and the opportunities that a strongly typed, statically typed language could offer to improving reliability on the cloud. And like Alexy mentioned at the beginning, avoiding us all becoming YAML developers.
Thank
Rúnar,
you.
You go next.
Next is Jana.
Oh, sorry.
Hi, I'm Jana Dogen. I'm a principal engineer at AWS, but most of my programming language work was at Google. I worked on the Go team for a while. I was actually one of the earliest members of the team. When the language was still small, it just took over. It became a more interesting language, I think, in this domain. And I initiated a lot of things related to Google Cloud's Go support. And before that, funnily, my first 20% project at Google was making Scala a Google Tree language, a language that is supported in our production. So I just went from two extremes, one extreme, of Scala to a language like Go. But I really want to talk a bit about maybe the runtime aspects, concurrency model, that sort of things. So if you have any questions, I would love to, see them. And who is next? Maybe Bill?
Hello, I'm Bill Venners, and I'm a Scala guy. I have lately this year been working on the 5th edition of this book, which is about Stoddy, which is a massive rewrite of the language, the compiler from the ground up. So we decided, since it timed well with the pandemic, we'll rewrite the entire book, and it's split into two volumes. So that's what I've been working on lately. And my feeling about the cloud was that it's it feels kind of low level, like in the old days of assembly language, maybe even, or maybe C, maybe not assembly, but I think maybe some programming languages or improvements or whatever can make it feel a little more high level. But that would require that you kind of have somehow cross the network and have things on both sides. And that's one of the things I felt is that like I compile to a JVM, let's say, and a different JVM, and then we hope that the protocol matches. So even just the type systems that we have, it would be nice to have type checking across those boundaries. But there's other kinds of type systems like session types that can actually not compile if the protocol doesn't line up, right? And then you can do things like static analysis to give you deadlock freedom. So I think there's like a lot of opportunities for that sort of stuff. But on the other hand, this thing is heterogeneous, and people just haven't in the past wanted to have like the same language across things. They wanted, these people use Python, these people use Java or whatever, and have them talk to each other. So anyway, that's my where I'm coming from with the cloud. So I don't know who's next.
Rúnar, I think, is the next in
Okay.
my Zoom order.
Hey, I'm Rúnar. I'm one of the co-founders of a company called Unison Computing, and we're working on a programming language and platform called Unison, which we're hoping will be a sort of operating system for the cloud. So where I'm coming from at the cloud is that it's same as Bill, basically. I feel like it's way too low level that, the cloud we see is kind of a new kind of computer, and it's early days yet. And so this computer doesn't really have an operating system. Like you might think like, oh, AWS is an OS for the cloud, but it's more like a BIOS. Like it provides, basic places where you can call into from a single OS process to get, some basic services. And even things like, Kubernetes or whatever. Kubernetes is just a big linker, it's not a like a shell for the cloud computer, which is what we hope to build. And the way that we're approaching it is that every program in Unison will have a unique address based on the hash of its implementation. So everything shares a vast global memory space, and you'll be able to call into basically anywhere in memory at any time in the future and anywhere on the planet and beyond.
Rúnar, Baruch, you're next.
All right. So, Alexey, thank you for inviting me my first time at Scale by the Bay, as I have very little to do with Scala. I'm a Java developer for the last 2001, 19 years, head of DevOps advocacy with JFrog. JFrog is a company that mostly talks to engineers, and in the edge of DevOps do tools that help DevOps, and especially in the cloud. And obviously our products support any possible, or not any possible, but close to most of the most popular programming languages. So we're pretty familiar with the ecosystems of each one. If I want to make a statement about the programming languages in the era of the cloud, I would say that now, especially in the era of the cloud, you need to ask yourself, why do you want to write something in one language and not other? And there are valid answers and there are less valid answers. And valid answers might be, I need my code to be very, very fast in runtime. And then you will look at the modern languages for that purpose, Rust, obviously. Or you can say, I want extreme productivity when I write this code, but then I care less. And I don't care about platform dependence because I run in Docker, and then you go with Go. Or you can say, I need a language that the people who are not necessarily developers can write almost a pseudocode and it will magically run. And then you obviously do Python, right? So those are kind of good answers to the question why. There are less nice answers like I want it on my resume, or I am in love with the language, or this is my religion. And it's all valid, but probably have less value as for the business or for the code that you want to run in the end of the day your code with. And with cloud, it's now even more clear because it kind of, as Alexey put it in the beginning, we have those consolidation forces. As the market matures and everything. And now it's true for the developer market. It's easier to find a developer with the popular language than the one that is not popular, and that promotes the popularity even more. But it's also true for interoperability, which is kind of might not sound intuitive, especially in the world of microservices, when we kind of, hey, why do you care? You just do REST API and everything talks HTTP and it's all YAML and JSON. But in the end of the day, if you have interoperability between modules which are written with the same language and the same libraries, the same architecture, this interoperability goes beyond what passes on the wire. So that's kind of my stand, and let's fight.
Thank you, Baruch, and I really appreciate you bringing your fireplace, because, I found that when I announce a fireside chat at a conference, I had some people coming in. If you don't really have a fireplace, they can ask for their money back. So it's very important, to have a fireplace if you declare a fireside chat. So next time I have one, I will follow your example, so nobody, can ask for a refund.
Absolutely.
So great. And last but not least is Bryan Cantrill, who has his own cloud now.
Hey, thanks. I'm Bryan Cantrill. I'm the CTO of Oxide Computer Company. We're actually a de novo computer company seeking to deliver the hardware and software benefits of what we call the public cloud to those who are running, who want to actually own and operate their own computers. It turns out there are people like that. So rack scale machines. It's kind of interesting when people talk about the OS as a metaphor, or the BIOS as a metaphor, because that's actually how I've spent my career, is in those literal artifacts, firmware, low-level system software, kernel development, operating system software, and control plane storage software, and so on. We do virtually everything new for us is in Rust. We are by design and also by because of the right tool for the job. We're a big Rust shop. I think Baruch made a very good point, and it's a point that I would really reiterate. In terms of the cloud, we live in an era of great language heterogeneity, and I think that is a tremendous feature. I think too often we have these languages kind of declare war on one another, and that does not make sense. And what I look for is, as someone who's spent a lot of time in C, I actually have written a lot of JavaScript. There was a time when I really had great ambitions for JavaScript in terms of its rigor that I ultimately gave up on. But I think when we look for a language and we're trying to match that to a task that we're doing, we want to find the values that we actually care about in that particular task. And this is what Baruch, I think, also alluded to. Do you need it to be, do you need it to perform? Do you need it to be debuggable? Do you need to be quick? Do you need it? Is this something that's going to be a prototype? Do you need to be written by a scientist? Do you need it to be accessible? And these are different things that come into tension, and not one language is very unlikely to be the right fit for all jobs. So I think we do a better job when we think, we do a better service to software engineers when we think about the values that a particular language might have, and then matching that to tasks at hand.
Thank you very much, Bryan. Now we'll let moderators ask some questions. I think Evan is up for the first question.
Sure thing. So I think following on from what Baruch and Bryan had alluded to about choices of programming languages. So it was said that it really depends on what tasks you want to do, and that's understandable. Everyone has different priorities. But do all of you think are there specific features of programming languages, there are platforms or communities that you think are more relevant for the cloud, for example, like type safety or other things, or do you think that doesn't really matter? Like what do you think are those important characteristics, if any?
Yeah, so I can go. I think obviously there are. And Alexey kind of threw it in the air and said, how do you develop to the cloud? We don't know that. And I think there is obviously everybody do what they do, but we have kind of manifesto for what development for the cloud is. And that's the 12-factor app and beyond the 12-factor app and 14, 18, 19. I don't know, by the way, why they're all like even numbers, but for some reason, the number of factors are always even. So one of those factors, or many of those factors, have a very significant impact on the selection on programming language. For example, the startup time and the teardown time. It's extremely critical for the cloud because of the scalability. You need to scale up, so you need to make your service available on new pods as fast as possible. And you also need to be able to kill malfunctioning pods as fast as possible, but also gracefully. So for example, if you take a programming language which takes the application takes very long time to start up, that will affect your ability to scale in the cloud. And there are many others, and type safety, for example. Well, again, I mean, if you are going to, if you do continuous delivery to the cloud, how certain are you that your code is doing what it's supposed to do? Well, the answer is never, always you have no idea, right? Because we can only test in production. The ultimate test will be in production. But if you manage to increase your trust in the code by having type safety, then you will obviously be in a better place. So for the cloud, I think there are very clear properties of a language that should be, and those that you don't care about. For example, platform dependency now. With Docker, you really couldn't care less.
Can explain like my also perspective from what I observed when I saw Go growing so big in this area. One of the things that a couple of things that we already mentioned, that like runtime initialization is just really fast because of the nature of the the platforms that you run in. You just want to really scale the resources up and down. Like, so runtime initialization was a big issue for tons of like runtimes for a while, and like Go was giving you this like small runtime, and we were putting everything in a static binary, so the the initialization was very hard, was not dependent on a lot of like external resources and so on and so on. That became a huge thing. And interestingly, all of these like command line tools started to like utilize Go for the same reason. So in the DevOps world, like it just became a thing because you would just write the server, and then maybe like if you have like any command line tools and whatever, you would still like rely on the same language and like be done. So that kind of like was a very compelling story for tons of people. In terms of deployment, also like static binaries have been really great. Like even though we have containers, people were like having difficulty distributing or like verifying and all of that stuff. Like just bundling everything into one simple thing was very like a good advantage. And if you think about like containers, like our container images are extraordinarily large because of like runtime dependencies and so on. A small static binary was very nice because you just kind of like end up having all these like 50 megabyte of a Docker container with all of your external dependencies in your server, and that was just like really nice to build, pack, push, distribute, and so on and so on. One of the other things that I actually liked about Go, and like tons of people I think liked it, is you don't really like cross compilation in Go was always a nice thing if you're not dependent on any C libraries. And the standard library came with all of this like networking packages, like HTTP, like all the stuff, like the JSON library, like stuff that you actually need. And they don't really require any like C compiler or whatever. So like being able to cross compile on your like Mac to targeting your like Linux machine, because in cloud your environment is most likely to be Linux. It was really like a nice story for tons of people. So I would say that like there's a lot to do with like like how fast and how small, and like the initialization and the packaging and everything just really contributed a lot to Go's success.
Hey, can I ask a real quick question of Baruch? You said platform dependency, you don't care, or do you mean platform independency, you don't care?
No, I mean, if I don't care, I don't care about both. But what I really meant, since it's all containers anyway, I don't really need my binary to be able to run on any of the 42 existing flavors of platforms. Okay, right? I just ship my machine as we spoke. So whatever I build it, this is what's going to run in production, and I couldn't care less.
Okay, cool, thanks.
Thank you.
That's, by the way, a very big hit to the JVM, right? Because their selling point is kind of going away. Once you, I mean, now you really, I mean, so Go is platform dependent. So what? You compile it once, that's your target platform, it's run in the cloud. Why not? So that's an interesting, that's a very, very interesting, very dramatic shift in the industry. One of the biggest selling points of the JVM is going away in front of our eyes. That's impressive.
So, Evan, you were asking if there are any kind of absolutes, and with a tip of the hand to type safety. I have to say, the older I get, maybe the more hardened I get on this. That on the one hand, you want to allow things to be done quickly. On the other hand, I've seen so much harm done in production systems by type unsafe code. That I actually think that one of the most important and unsung developments in programming languages is actually TypeScript, where because JavaScript gave us a real false dichotomy where we were forced to live in a completely failed state from a programming language's perspective. And it's really challenging when you have these errors that are effectively typos that you don't see until they're running in production. And that's really unacceptable. And we should demand better. And I think TypeScript is a very important innovation in that regard. And I think type safety is something that we really need to demand of ourselves. And yes, it shifts cognitive load slightly in that one is forced to slow down ever so little to actually give the programming language some hint as to what you want to go do, so it can help enforce your own rules. But I feel that for just about any language, we need types. Types are actually a really good innovation.
I'm ready to disagree if someone wants to, like, if that's what you need in your lives. But if someone else wants to say something else, go ahead.
Well, I would second what Bryan has said. I think type safety is very important. I think also one of the biggest challenges in developing for the cloud, especially when you have microservices, is that the whole time your APIs and your integrations are evolving. So you're often not just developing for one particular current state. If you're deploying a microservice, it has to be often compatible with the current production version and the next version, because you want to sort of move these things in lockstep. And that I think is one place where I think some new developments in type theory could be very useful. So things like dependent types. You could potentially have a type representing your old version of the API and a type representing your new version. And you could branch the code exactly where you need to for the old version or the new one, checked by the compiler, putting your trust in the compiler to verify that in the same way that you trust the compiler to verify that you won't get linking errors at runtime, but just extending that outwards to the cloud. I think that's an area of opportunity for applying type theory and some of the newer developments in type theory to avoiding what is the equivalent of linking errors in the cloud.
Yeah, that's fascinating. The disagreement that I wanted to bring is not necessarily anything to that you say. It's obviously very important. And you know what? Defining an API version as a type is mind-boggling, because that will solve so much pain for our development for sure. What I wanted to say is that there is a very clear niche for programming languages with dynamic typing, and it's not a cloud. It's not like the ultimate production, if you wish. But we spoke about the data scientists that are using Python heavily. And the reason they're using Python heavily is because it allows them to write a pseudocode that eventually runs. Adding type theory on top of that will definitely make them, if you wish, have to be a developer in order to express their algorithms and see if they are working. And this is something that I think won't be acceptable. I will give you an example. My wife, she works in search engine optimization. And she's not a developer. She never learned a programming language, but now she's using Python for example, to build models of how sitemaps should look like so they will be indexed better. Yeah, she's not a developer and she's writing Python. And if when I make fun of her, hey, you are a developer now too, she's like, no, I'm writing algorithms and it works. So adding types to that will be a disaster. And I think there is a very clear niche for this type of programming languages as well.
I completely agree with the like mental overhead of versions. Like, for example, I can give an example which is like not like super nice or whatever, but you know, cloud providers have all these APIs. They have minor and major versions. Like once there's a major version, they auto-generate new client libraries. So like you can say that like some of the new types are actual versions. But you know, like you have package versions and then you have API versions and you have some other like compatibility versions that, you know, it's just kind of like becoming such a huge mess for the user because they have to understand and navigate the entire mental model. And, you know, it's just more of like trying to figure out like what version matters for them. And like, it's kind of like, I think, losing the value because of the complexity of the complex nature of the situation. So I'm not sure like what is the best way to do this. Like at Google, all the APIs were really simple because, you know, the company had has this like mono repo, just go and fix people's bug like issues if, you know, you're deprecating something. But what was interesting was like in your service description, you would never actually like delete things. You would only add new stuff and you would just deprecate the older like APIs over time and go fix people's bugs. But in the protocol level, in the VAR level, you would still support it just in case somebody hasn't upgraded. Like maybe like some more pragmatic solutions like that is the way to go. I'm not sure. I've seen like so much like version mental overhead come in, you know, because it's inevitable. So I'm also skeptical about that.
Hey, Rúnar, can you describe how you do that in Unison?
Yeah, I wanted to address that. So in Unison, okay, so the problem is like John said with the linking, and Jana, you were describing this as well, where, you know, you want to call into some code that's somewhere else. And it's exactly the same problem with binaries on your machine. Like they're in different places in memory, and then it's the linker's job to make sure that you call into the right thing. And dynamic linking is the same. You know, you want to call into the right DLL or SO object or whatever. But you know, once we move to the cloud, it's like, oh, all of a sudden, like we're writing code that for like single processes, and then we call into other processes using like these network protocols and stuff. And so what we're aiming to do in Unison is that you'll just have the API of the thing that you're trying to call as a first class thing, and it gets compiled with your program. And then you simply tell the other location, hey, I want to run this code. Like, you know, here's the actual hash of the API that I expect to be calling. And it's all checked at compile time. And so that whole linking issue, we're hoping will just go away. And so, great.
So just my understanding of this is basically that every expression is like a function that has holes you fill in and then you can evaluate it, and they hash that as they make a hash of it so that when you link between things, it's based on the implementation hash. So that's sort of the version, but it's very low level. So things will always get the one that they were compiled against, the ones where they said, this is the hash I want to use, no matter what happens later in time. So the question then becomes, I think for me was like, well, how do you update? Like I want to do a new version of something, you know?
Right. You update in a very first class way. Like for instance, you could have a queue of, you know, versions of an API or, you know, some code that you want to run in the same location, and just have it listen on a queue and update itself by reading the next version off the queue in a very first class way.
I think John had raised a good point about how we can use what have been some more arcane elements of type theory in the kind of in boots on ground in the cloud. Speaking personally, and I'm a systems person, I'm not a PL person at all. But honestly, algebraic types have changed the way I think of errors in the cloud, the way I process that. I mean, that's thanks to Rust, really. And I having worked now with algebraic types in Rust, I couldn't go back to actually dealing with errors any other way. I think that the compiler is able to help you out so much. And I wonder if there are other innovations like that. Obviously like to see that innovation brought to many more languages. I think, Baruch, you were talking about, your wife working in Python and how types would be a disaster for her work. And maybe the which I don't question or doubt, maybe the question that folks need to ask is how important are errors to the code that I'm writing? Because that's, it's kind of like music, the difference between an amateur musician and a professional musician is often their ability to do error handling. And I had a drummer once tell me that it required great error handling to be a professional drummer. And maybe that's the question we should be asking of these, as we are endeavoring to write new code, how important are those errors? And I think if errors are important, you've got to have algebraic data types to help you out.
Well, certainly from the point of view of a developer who works in a statically typed language, most of my time is spent understanding error messages, working out what they mean. And I think the Python example, to understand the errors I work with, I've had to go through years of experience with types. So that is not true, I believe, of a Python developer who is encountering errors. They're more
or Python user, not a developer.
Sure.
Sorry, John. I was just
no. I just felt like I should say something in favor.
Yeah, no, you're absolutely right, and that's exactly my point. It's not that I think that adding types will do harm to Python. What I'm saying is, if you the barrier for entry to Python should remain, or any other language, right? Doesn't have to be Python. Today we will pile a bunch of stuff which makes entry level to Python is hard. Tomorrow a new language with a small entry barrier will come in. But I'm saying there is a very clear usage for those languages for which you don't need a science degree in computer programming or computer science in order to be able to write a code and to write an algorithm and see a result.
You don't need it to get started, but I think the longer you spend, the more time in your life you spend dealing with runtime errors, I think the more you're missing out on the opportunity, like Bryan suggested, of types and the you talked about the speed of getting started. You start to feel the pain of having to deal with the runtime errors after you've started. And
I think it. Sorry, go ahead.
No.
I still think that it just really matters, right? Like if you just want to write a small map function or a reduce function, something like that, you just want to throw away and see what's gonna happen. Like you don't care about types at that point. And if you're dealing with data, especially, you don't know what's the schema and so on and so on. So it just makes perfect sense to work with a dynamic language. But yeah, if you're working with a giant code base and need to maintain layers of abstractions and so on, even being able to actually rely on some static analysis tools is just becoming such a core requirement in that thing. So I would say that I would go with a statically typed language just for the sake of being able to use some of those tools. But also when we're talking about type systems, there's different entry barriers to different type systems. If you take a look, Java's type system is just more involved, more variables. Maybe that's what I would say personally, from my personal opinion. It requires a hierarchy. You just need to put the classes in certain ways in certain files, and that's just so much overhead for some folks who are coming in. But in some languages, types are just you can introduce types on the fly more easily. You can compose them more easily, or you can just organize the code base without thinking too much about you can introduce types maybe at a later time and so on. So there are different nuances here depending on the type system as well.
You mentioned the size of the code and saying that static types are very beneficial for large code bases. I think in the case where you have a program where when you run it, that runs the whole program from beginning to end. Every piece of code is run in one go. If it's small enough that that can happen, or if it's simple enough that that can happen, then the type system isn't really bringing you much. The compilation step doesn't bring much to developing that program. But as soon as it gets beyond that, that's where I think the benefit starts to come in. Even if there's sort of 3 or 4 branches and you have to try different versions, getting those runtime errors to actually be invoked is much harder than just seeing the errors in a compiler.
So
yeah, I completely agree. It just relies also on like, how likely that you will actually hit a runtime error, right? Like it's more of like, are you in a very self-contained situation and like just doing all the high level things, or are you actually like impacting what's going on underlying, like in the underlying stack? So it's again depends, but this was not a really good answer. Sorry, Brian.
yeah, no, I think that's a very good point. And I think, John, I like that kind of rubric of it, is it small enough to be able to run in one go? I think there are 2 other questions I would ask. The crystal ball that I've always wanted is this line of code that I'm about to write. How long will it run? How long will it be out in the world? Is this something that will post-date me? I have written code that I absolutely know will survive me long after my death. And then there's also lots of code that is, I'm going to run, this is an awk pipeline. I'm going to run this code once and I'm never going to run it again. And if I could know that all of the time, because I think we've all been surprised by code that has clearly survived longer than the original author intended. We'll give them the benefit of the doubt. And we will say, if you knew that I would come up to this code 8 years later and be debugging it, I'm just going to assume you would have done a better job when you originally wrote it. And I assume—
I'm encouraging like rewrites like every other 2 years. Like that's literally my interview question when I'm interviewing with a company to the company. Are you doing rewrites? Like if you're not doing rewrites, I will probably be very unhappy here, because yes, I've seen so much stuff like surviving their like timeline.
So that's interesting. I mean, that's an interesting point. So you want to see stuff rewritten, which I think is good, and I understand that. But there's also code that is so much deeper in the stack. I mean, we were using the bias as a metaphor earlier. We are all running code in our computers that was written in the 80s, and we, there is some code that is going to be really foundational that we don't want to rewrite. And how do we kind of divide that? And then how does that inform the programming language that we pick?
I think one of the aspects that we never talked about is like the diagnostics aspect, right? Like what we actually expose from the, the runtime, like especially like working on a language that didn't have really good error handling. Like I'm talking about Go for a long time. And, the other difficulty was that it's a statically, linked, like it's a static binary. So you can't really like introspect at a later time. You actually have to put the right bits before, while you're building the binary. So you can go and like introspect it in the, production. So that's also another aspect. And I would like to, hear some more opinions on this topic.
Yeah, this is great. Just want to follow up on that. Like it's we should definitely talk about tooling and what do you think are important parts of the platforms, and also I think like Bill, I don't know if you have like opinions on all of this, and then the other like related one is I know there's a lot of folks in this conference who are like JVM users, and I think earlier it was talked about that maybe it matters less than the support for platform independence. So it would be great to hear from some of you also to talk about the platform that is the JVM and if that matters.
This is Bill. Let's see. I was just thinking, as far as static versus dynamic, we kind of did that same debate, which is like the same cloud or no cloud, I think. But what I think is interesting about cloud with static versus dynamic is, will static types be used across network boundaries? That's what I'm kind of curious about. And I've seen that tried before. I think Unison is an attempt to do that. And Genie?
No, actually, we do away with that.
Okay, well, why don't you maybe explain that? Why?
Right, so you just deploy the code that you want to have run. So there's no actual API calls across the network boundary within Unison. You just call Unison functions and they're running at a different location.
Yeah, but that's what I mean, I think.
That's like RMI, circa 1995.
Yeah, or Genie.
No,
But
it's
that's what I
nothing like
think.
that.
Genie was say, let's just assume there's a JVM everywhere. And then, you know, the protocol is actually a Java, like dynamically loaded Java class. And it just didn't take off. People wanted to actually it was heterogeneous, and they wanted to talk XML at the time, now JSON. But anyway, that's what I'm kind of curious about is the extent to which things like that, where the language kind of, I deploy it and it's actually on the network, it will happen in the future. I think tooling is another thing. I mean, it doesn't have to be language. A lot of what could make this more high level is tooling. You know.
Yeah, some more YAML tooling will do it.
So.
Can I ask about YAML tooling? Because it still boggles my mind that after 20 years of effort and best practices, we all kind of descended into YAML hell. And what is it about the community? Because it's programming languages are social phenomena, right? So I think it's very interesting to see that some of them succeed not because they're good, but because they're popular, and it's still mysterious what drives popularity. So if you look at Go, obviously it has backing of Google, and Python happened to be there when data science appeared, and so forth, right? So, but what does it say about the community or the forces driving it that we all now became YAML programmers? And what do you think about that, right? Why not? Like, we have, for instance, DAL is a type configuration language, but nobody is talking about like putting DAL instead of YAML. So I wonder what folks think about, what does it portend for the future of the cloud that we all have to become YAML programmers now?
I have opinions on YAML. I think, first of all, I would like to think good of our community, of the developers and the engineers. So I want to blame this YAML situation on a complete chance and not like this is the best we could do. And I think it is partly, as you said, popularity versus how good it is. It's not necessarily the winner is the quality. And I think that's one of those cases. Someone back in the day decided that YAML is a nice markup language and has benefits on JSON and gave it a try. Next thing you know, we're all YAML engineers, right? It's just happened. And today, when you build a cloud native tool, and I will give you JFrog as example, we have a relatively new tool that was born into the YAML edge, the JFrog pipelines. And when we assessed which markup language or domain-specific language our pipelines should be described in, we decided on YAML just because it is what it is today. Right, we will still probably do domain-specific language, and you will be able to write the same pipelines in Kotlin and Groovy and what's not. But we started with YAML because this is what everybody expects from us right now. The only one which tried to go against this this trend was Jenkins with their Groovy DSL in pipelines, and I think that they're both writing those pipelines and reading those pipelines are much more improved comparing to YAML, but all you hear is how much people are hating it and how much people want something that they know, which is YAML back. So it's definitely a popularity contest by now, and we just need to brace ourselves and wait until it's over. Hopefully that the next big thing will be a domain-specific language and not yet another horrible markup language. It's like yet an YA-H something something. Yep.
Anybody else has opinions on this?
I have opinions as well, but many people have opinions.
Yeah. I just want to speak to the instrumentation point that was brought up earlier, because it's a very important point. In terms of the ability to actually instrument programs and software to figure out what they're doing, something that's obviously been very near and dear to my heart. So I years ago developed something called dtrace that allows us to instrument running systems. It's been something I can't live without. I think that it is, while we were able to add some support for dynamic languages, the dynamic language problem is really, really hard from an instrumentation perspective. And it's when you have a static language, that is, say, generating a static binary, there's a lot more you can go do. And one of the things that I would want to call on all languages to do, Rust has actually done a very good job of this. The idea of having debug information in your binary is not in conflict with having an optimized binary. So if we can have an optimized binary that we deliver that has a rich dwarf section, I don't love dwarf, but dwarf is very rich, that fully describes how tooling can understand that binary, we can build really rich tooling on top of it. And that, as basic as that is, it is not something that has permeated. And actually, Rust is the exception in that it is able to generate an optimized binary with dwarf information in it, which I've been very grateful for. But I think anyone developing a programming language, that debugging information is really essential to build the kind of tooling that Jana was mentioning.
Is the problem programming languages themselves? Should we be using data for a lot of this information rather than executable code that modifies global mutable state?
I think yes and no. Like I think, you know, like on the one hand, I think there's patterns you can use in every programming language, right? But on the other hand, I think there's some support that is good. Like for example, async programming is so hard. And like if you look at the JVM, for example, like it's been built and all of the IDEs and everything have been built with kind of like single threaded execution in mind, right? Where like basically everything is, and that's how people, you know, debug things. And so it'd be great to see a shift in paradigm to like kind of really embrace really good tooling in terms of like debugging async and distributed programs. And, you know, you have tracing, distributed tracing, and like good concurrent support. And some of that does have to do with the programming language and the platform.
There's also like a bunch of, you know, building blocks needs to be done. Like, you know, I spent last 2 years before switching to databases, and now I'm back in the same area in distributed tracing. And, you know, like the way that you propagate the traces, for example, in the runtime, I'm not even talking about, you know, what you do on the wire. I'm talking about like how you propagate things in the runtime is not like, you know, there's no consensus on it. Like, you know, in Java, there is all this like different, you know, propagation libraries that relies on different, you know, some of them are like using thread local, some of them are doing their own thing, some of them are like explicit libraries that you actually pass the, you know, context here and there. So like, I think that we just really need to sit down as the industry and like acknowledge that this is an issue and like set the, you know, the foundational layers. Because right now everything is kind of like a patch, like we're just enabling a couple of cases. If you do all of this 100 things correctly, and, you know, nobody really has time, or nobody wants to invest that much of time to, you know, get that like little value. But it, you know, everything was just, the building blocks were there. It could have been so much easier. One of the things that I like about Google was the RPC stack. We were using GRP, I mean, they are right now, I'm not working at Google, is this common foundational block. And, you know, the context propagation is using this common thing. So, you know, everybody knows that, you know, they can rely on that like incoming context to take a look at some of those things. So, you know, just kind of like making larger changes, like, you know, adding distributed traces or whatever, just so easy because that foundational building block is there.
If this is a pause, I have another subject. I just kind of curious. One of the problems I've seen in enterprise software is people have problems on the JVM with 30-second garbage collection pauses and sockets timing out. Like Rust, I think you wouldn't have that. I'm just kind of curious. Like I know the garbage collectors keep getting better to try to catch up. It's always like a race between these two. To what extent is that an issue? Like, as far as that is a programming language question, it's because like Rust makes you say when you're going to free things, right? Java does not. Just I was curious if anybody had an opinion about that, how important that is.
I mean, I definitely have an opinion on it. I was going to wait for Evan to give his opinion on it because I think that
I could give my opinion too, but Brian, go ahead.
Well, I'm going to actually, you know what? I'm going to give Evan's opinion on it is what I'm going to do because I saw Scale by the Bay 2018, right, Evan, where you had your presentation, and it was basically some very sophisticated tricks that Evan was using to like, how can I just at total war with the GC to try to generate high performance. And the amount of work that was required, cognitive work, felt so much greater than the work required to simply indicate to the compiler when memory was being used and when it wasn't being used. That I think if you, there's definitely a point where GC is clearly a win at some level, it is clearly not a win at some other level. And I think it's tough when you have a system that kind of starts at one point and drifts to the point where actually GC is no longer a win. And it would be much wiser to actually manually manage the heap with a type-safe language, memory-safe language like Rust.
Yeah, and I'm seeing like that shift is just really, making the source code really terrible. If you started with a garbage collected language, like just basically rely on a lot of like self-management type of tricks, and things are becoming unreliable, unreadable, especially if you're onboarding a new person, like just kind of like explaining like, hey, this is the memory management tricks, and like just don't use like this as a regular package or whatever, right? Like just you have to, that just like creates a lot of like problems. And the shift is like more, I think, common than what people think, especially like when projects are starting small. Tons of stuff related to memory is just like very underestimated, or just you definitely don't care. But like as I'm telling you, like rewriting maybe is a good solution to all of these problems, but that's also not happening way too often. So yeah, it's almost like your entire model of like your program is becoming more of like you thinking about the memory management and coordinating the tricks around it and so on. So
yeah, just to follow, thanks.
Did we lose
I
everything?
think GC fine, and it takes care of the most common cases. But I think more and more as the volume of data expands, and people do push the envelope more. Like I was doing database stuff, and as people push the envelope more, and CPUs are not getting faster, you'll find that it becomes, people have to start looking like beyond and recognize the limits of what they have, and that's true of GC as well, and find a paradigm that works.
Great, thanks. That was interesting.
Folks, I just want to note that we have 3 minutes left on the clock. After that, we all will go to a different Zoom. I will post the link momentarily, and I'll tell you guys when to click it. But maybe we'll just use this kind of few remaining minutes. Maybe everybody can make a very short closing statement for this panel, for this segment. Kind of what are you gonna do about the cloud in the next year? Let's say very simple, like where do you kind of place your bets? What's exciting, or like what are you gonna do about the cloud in the next 12 months before next Scale by the Bay? And we're gonna check next year whether you did this or not. 30 seconds each. Let's just start with Bill.
I was afraid you're going to start with me. I don't know. Basically, I'm actually stuck because it's pandemic. Things are different now, and so I'm more in the Scala 3 programming, trying to figure out how to explain it mode. So maybe not so much with the cloud. That's what I'm focused on, is all the new features in Scala 3 and the transition from Scala 2 to Scala 3.
And Scala Test 2? Scala Test as well?
Scala Test already runs on Dotty on Scala 3. It's called Dot. Dotty was the name of the project. Scala 3 is what it'll be called when it's released. It's supposed to come out RC1 in December. And, it's Scala. So it's like Scala was popular for a lot of things in the cloud, microservices and whatnot. So
you're ready for the cloud. You're already done. Good. Jan, how about you?
I don't know what to say. I'm going to keep on using cloud services. It's the future still. Nothing's changed.
Fury, your answer to the cloud in a way? Can you construe it as an answer?
Fury. I mean, not in 30 seconds. I can't. But yeah, I have an interest in evolving ecosystems of libraries and published artifacts, and yeah, the cloud.
We should all cloud things.
Yeah, the cloud is a necessary aspect of that.
Okay.
You're muted, Alexy.
Evan, how about you? Your next year for the cloud.
Oh, hey, I don't. I mean, there's been so many good thoughts. It's really hard to like summarize it, you know. But just hey, I think it's going to be like, you know, really interesting. We'll see a lot of innovation in the, you know, in the coming, you know, years. That's it.
All right, Jana, are you gonna rewrite AWS? Was the part of grammar?
Well, that's sort of my 10% right now, to be honest. But actually, you know, I'm more invested in observability, like diagnostic side of the things. I do believe that that's just like a, you know, urgent thing that we should figure out. We're talking about languages, but if you think about the whole stack, like, and the complexity and like the growing complexity, it's just like you know, you have to give users like some sort of visibility, right? Like otherwise none of this thing is gonna scale. Even engineers working on some of these systems don't understand the systems well. So I do believe that tons of like language work will be also like focused on this in the long shot. And I hope that I'm right.
Thank you. Bryan, your next year for the cloud.
Yeah, so boy, our next year is going to be a wild one. We've got a lot of software and hardware coming. The cloud is way deeper than you might think. We've got a lot of firmware coming in Rust. We've got a de novo operating system coming in Rust. We've got a lot of stuff coming that'll all be open source in the next year, which will be fun. What I want to see though, this is not going to be what I'm going to be doing, but what I want to see in the cloud, there is far too much bash, load-bearing bash in the cloud, and Bash is garbage from a programming language perspective. It is a collective embarrassment that we don't have something that does Bash but better. So anyone who's interested in programming languages and systems programming, there is a real opportunity here for a scripting language, but one that is type safe, or certainly not the absolute menace to society that Bash is. Even I laud Bash's contribution to humanity, but it's time to replace it. That's what I have to say.
Not Bash embedded in YAML.
Right, exactly.
Thank you, Bryan. So the destruction of Bash for the next year. Rúnar.
Yeah, so I'm going to be focusing on getting Unison, the programming language, to public beta, so sometime early next year. And hopefully by the end of next year, we'll have a Unison library for deploying Unison programs to the cloud.
Thank you, Rúnar. Wiem, what's new for you next year for the cloud?
Currently, I'm very, I work a lot with AWS services, and I'm interested to learn more about them. And my goal is also to learn Unison, get started learning it, because I saw that it is easier, less effort to deploy. And I also like writing Scala. I will also do both of them. So yeah.
Thank you, Wiem. So we got the first user for you, Rúnar, here. And Baruch, what's in the cloud for you for the next year?
Yeah, so in terms of programming languages in the cloud, I don't expect a lot of changes. I think the containerization is here with us, so it will be Go all the way. More and more Go running in more and more containers. In cloud in general, though, I do expect to see a shift. I don't know if it's like a year or 5 years perspective, but I think we are looking at the next frontier, which is edge computing, cloud computing, and distribution to devices. IoT is kind of already has a bad reputation, so we need to rebrand it, as we usually do with stuff that gets bad reputation. So edge and fog computing is the next big thing. They will still run containers, so it will still be all Go in the end of the day, but I think this is where the cloud is going.
Thank you, Baruch. I think the edge and fog actually are important parts of the cloud we didn't touch, but that's certainly coming. And we have this topic of AIoT mentioned earlier this morning from VP of Innovation at Bosch, right? So the cloud has different forms, and some of them is programmed in the unspeakable, unfathomable ways we don't even imagine because they're so small, so big. So this is great. Thank you, guys. Let's now.